My dear students, welcome to Easy BTech, your guide for BTech and beyond. We are discussing about subject signals and systems, and today's topic is we are going to do problems on Laplace transform. So how to do Laplace transform problems. Let's start our session. Problems. So first I am taking a problem. So before going to problem, let's have a small discussion about S-plane. What is S-plane? Okay, after that we discuss about problems. So let's see S-plane. S-plane. So in Laplace transform we have complex variable S. In Laplace transform, complex variable S is equal sigma plus j omega. Sigma plus j omega. So here sigma indicates real part of S, j omega. Here omega is the imaginary part of the S. So now I am taking this real part as x-axis and this j omega as y-axis or vertical axis. So x-axis is real part of S, sigma, and y-axis is imaginary axis j omega. This is imaginary axis and this is real axis. Okay, and about vertical axis, the left side, left half of S-plane, this totally left half of S-plane of S-plane means sigma is less than 0, and here it is right half of S-plane, right half of S-plane, sigma value is greater than 0, sigma is greater than 0, and this area or this is called S-plane, the total is called S-plane. So in Laplace transform we have complex variable S which is equal to sigma plus j omega. So here sigma is the real part which is x-axis and j omega imaginary axis, y-axis, left half of S-plane, right half of S-plane. So let's take a problem. Find Laplace transform of given signal x of t is equal to e to the power minus at u of t and find its ROC. So whenever you are doing Laplace transform, ROC also we have to do, right? First ROC, then we get the Laplace transform answer or result. So ROC is first, then Laplace is next. So we know Laplace transform formula. What is the Laplace transform of signal x of t is equal to capital X of S is equal to integral minus infinite plus infinite the given signal x of t into e to the power minus st dt. This is the formula, Laplace transform formula. So the given signal x of t we take, then integral minus infinite plus infinite e to the power minus at u of t into e power minus st dt. So here u of t is the unit step signal, right? So u of t is a unit step signal which is available from 0 to infinite. So I am plotting here, you can observe u of t. So the value of u of t is 1 after 0 or 0 to infinity. So as per u of t or according to u of t, this integral limits we can write 0 to infinity, because minus infinite to 0, u of t is 0. This u of t is 0, no need to do that integral. So e power minus at into e to the power minus st dt. So here I am going to take common 0 to infinite integration. I am taking common minus s plus a. In the power I am taking common minus and t also common. So e to the power s plus a, right? So we always we always look for, after substitution of limits, we always e power minus infinity, which is equal to 0, right? We always think we should have e power minus infinity which is equal to 0. So here upper limit is plus infinity, lower limit is 0. No problem with the lower limit, because e power 0 or minus 0 it is 1. So upper limit is infinite. Already in the power we have minus. So this s plus a should be positive, right or not? S plus a should be positive. So this is called, this way of thinking is called ROC for this given signal. This point is called ROC. So what is ROC? This s plus a value should be greater than 0. Real part of s is, or real part of s plus a is greater than 0. So real part of s is greater than minus a. Real part of s is greater than minus a. This we can write in the next step. Here s plus a is greater than 0. So in s, real part is important. Real part is important one. So real part of s is greater than minus a. Real part of s is greater than minus a. Right? Then we perform the integration. We do integration of this. So integral e power minus s plus a t divided by minus of s plus a, and here limits are 0 to infinity. Limits are 0 to infinity, which is equal to e power minus infinity after taking limits, or after substituting limits, e power minus 0 divided by s plus a. Okay, so we have minus e power minus infinite is 0, minus 1 by minus of s plus a. So it will be 1 by s plus a. This is the answer. So Laplace transform of e power minus a t u of t is how much? 1 by s plus a. And we have to plot ROC of this signal. So this is a real axis, or real part of s, and this is imaginary part j omega. Okay, 1 by s plus a. So you equate the denominator s plus a is equal to 0, s is equal to minus a, right or not? So take the point in s plane. What is the point? S is equal to minus a, so negative. This is the minus a, right? Now I am drawing a vertical dotted line excluding this minus a. Don't take minus a. So what is ROC? In this problem, what is ROC? Real part of s is greater than minus a. So take the point minus a, draw a dotted line across minus a. Now greater than minus a. So this is the greater than minus a. So I am drawing lines which is greater than minus a. Okay, here s equal to minus a, this is called pole. What we call this point? Pole. So ROC, we are not including the pole. Pole is excluded, because if you take s equal to minus a, 1 by minus a plus a, it will become 1 by 0 infinite. Right? So that is why we don't consider pole, or ROC doesn't contain any pole. ROC does not contain any pole. So this is the problem. Similarly, from this we can tell, suppose e power minus 2t u of t Laplace transform. What is the Laplace transform of e power minus 2t of t? In the place of a we have 2. So 1 by s plus 2. And what about ROC? ROC is real part of s is greater than minus 2. This is the ROC. Right? Done. Next, another problem. So here we have u of t, unit step function, Laplace transform. Unit step signal Laplace transform. What is the Laplace transform of unit step signal? Simply, so this u of t, unit step function means u of t. So already we know unit step function how it is like. So this is a unit step signal. Amplitude is 1 and it is denoted as u of t. So what is the Laplace of u of t? So normally by formula we can do it. So what is the formula? Laplace transform of a signal x of t is equal to x of s is equal to integral minus infinite to plus infinite x of t into e to the power minus st dt. So here the given signal is u of t, right or not? So take that u of t, integral minus infinite plus infinite u of t into e to the power minus st dt. The given signal is u of t, that we are writing as usual. Here u of t, if you observe u of t, it is 1 for t greater than 0, right or not? For t less than 0, u of t is 0, u of t is not defined. So because of that u of t definition, the limits now 0 to infinite only, and u of t value is 1, so 1 into e power minus st dt. So here e power minus st, right? So here upper limit is infinite and already minus sign is in the power e power. So we want always e power minus infinite 0 after integration, after keeping upper and or lower limits. This we want. So how do you get it? That depends upon here s. So the s value should be how much? Positive or negative? That thinking is called s is greater than 0 or s is less than 0. That thinking is called ROC. So here ROC is s is greater than 0. S means here real part of s is greater than 0. This is the ROC. Right or not? Then positive here, plus into minus minus, after taking upper limit e power minus infinity, which is 0, safe. Let's proceed now integration. E power minus st by minus s, and limits are from 0 to infinity. So upper limit is e power minus infinite, lower limit is e power minus 0 by minus s, which is equal to 1 by s. The answer is 1 by s. Okay, now I want to plot ROC. How to plot? S plane, we go for S plane, real axis, imaginary axis, and we have pole at s equal to 0, right or not? In the denominator only s is there, so s is equal to 0 is the pole, s is equal to 0 is the pole. This is the pole. So I am indicating pole by cross mark at s equal to 0. So this is real axis and this is imaginary axis, and we call it as S plane. Now real part of s is greater than 0, so I am plotting now ROC. So this is the s is equal to 0 is excluded, now greater than 0. This is the greater than 0. So this is the ROC. Real part of s is greater than 0. Right? Now the same problem we can do. This u of t Laplace we can do. So previously we have e power minus at u of t. The first problem we have done, e power minus at u of t Laplace transform. What is the answer we got? 1 by s plus a. Suppose let take a is equal to 0. Then e power minus 0 is 1 u of t, right or not? So u of t Laplace transform will become 1 by s. Simple. 1 by s. So in this way also we can do it. Right? And ROC also. Here what is the ROC of this 1 by e power minus a t u of t? Real part of s is greater than minus a. So here a value 0 for u of t. Real part of s is greater than 0. Okay. Let's take another problem. Another problem, Laplace transform. Minus e power minus at u of minus t. This is a given problem. For example, it is x of t. So previously we have e power minus at u of t. Now minus of e power minus at u of minus t. So this is generally u of minus t. The e power minus at is multiplied by u of minus t. It is a left-sided signal. Left-sided signal. And it is a e power at u of t. It is a right-sided signal. The signal is multiplied by u of t. It will be right-sided signal multiplied by u of minus t, left-sided signal. So let's have the Laplace of this function, minus of e power minus at u of minus t. So formula, Laplace transform formula, we know that Laplace transform of x of t. Laplace transform of x of t is equal to x of s is equal to integral minus infinite plus infinite x of t into e to the power minus st dt. Minus st dt. This is the Laplace formula. Now the given signal as it is we can take in the place of x of t. So minus e power minus EAT, right, u of minus t into e power minus st dt. Just the signal we are taking, whatever the given signal. Now that minus sign we can write outside, but u of minus t we have to think about u of minus t. So folding of u of t. So this is u of t. Now folding of u of t will become u of minus t. That's all. Folding of u of t is u of minus t. This is u of t and this is u of minus t. That's all. 0 here. It is 1 u of t and this is u of minus t. Amplitude is same. So u of minus t is 1 for t less than 0 and it is 0 for t greater than 0. That is the clarity about u of minus t. So according to u of minus t we can do now Laplace transform minus integral. So here it is 1 from minus infinite to 0 and e power minus at into e power u of minus t value is 1, so e power minus st dt. So here bases are same, so we can add powers. So integral minus infinite to 0, we can take minus common, then it will be s plus at, t also common, dt. So here upper limit is 0, no problem with upper limit, but lower limit is minus infinite. So already in the e power we have minus, right? And we want always e power minus infinity is equal to 0. This is the logic in Laplace transform. E power minus infinity we should have, we must have. That depends upon s plus a. So s plus a should be negative or positive, so that e power minus infinite will be 0 after substituting lower limit. So this s plus a must be negative, because negative, negative, positive, then limit is minus infinite, therefore e power minus infinity right or not? So this thinking is called ROC. So here ROC is, what is ROC? S plus A should be negative, means less than 0. So in S, real part of S is, right or not, less than minus A. Real part of S is less than minus A. So this is the ROC. Then we go for integration. E power minus of S plus A t divided by minus of S plus A, and limits are from minus infinite to 0. So substitute upper and lower limits. Here minus minus plus, so upper limit is 0, e power minus 0, and lower limit is minus infinity. Already we discussed S plus A. S plus A is negative, so minus minus plus, again minus infinity, e power minus infinity by S plus A. This is the way of doing Laplace problems. So 1, right? E power minus 0 is 1, and e power minus infinity is 0, so 1 by S plus A. This is the answer. Okay, and if you plot ROC, if you draw ROC, x-axis, y-axis, and where is the pole? S is equal to minus A is the pole. S is equal to minus A. So take the pole at minus A, only real pole, it is on real axis. So draw vertical line, dotted vertical line, excluding minus A. And this is the real axis sigma, and this is imaginary axis j omega. So less than minus A means left side, the ROC is less than minus A. This is the less than minus A. Okay, this is the ROC. Real part of S is less than minus A. Right? So on one more problem we can do. Another problem is x of t is equal to, find Laplace transform and ROC. X of t is equal to e power minus 3t u of t plus e power minus 2t u of t, and find ROC. ROC also we have to do. Right, so here we have two exponentials, e power minus 3t u of t, e power minus 2t u of t. So let's go to solution. Already we know that e power minus 8 u of t, Laplace transform of e power minus 8 u of t, this we know already. What is the answer? 1 by S plus A. And what is the ROC here? Real part of S is greater than minus A. So if you take x of t, Laplace transform of x of t, Laplace transform of x of t is equal to Laplace transform of e power minus 3t u of t plus Laplace transform of e power minus 2t u of t. So this Laplace transform is 1 by S plus A, means 1 by S plus 3. And what about ROC here? So ROC is real part of S is greater than minus 3. Greater than minus 3. Plus in the second signal e power minus 2t. So 1 by S plus 2. And what about ROC here? Real part of S is greater than minus 2. Okay. So here 1 by S plus 3, 1 by S plus 2, we can do LCM. 1 by S plus 3 into S plus 2. Here in the numerator we get S plus 2 here plus S minus 3, sorry, S plus 3. So this answer is S plus S2S plus 5 divided by S into S square plus 2S, so 3S, 5S plus 6. So this is the answer. And final ROC, here we have two ROCs. Real part of s is greater than minus 3, real part of s is greater than minus 2. Right? So final ROC is, the overall ROC or final ROC is intersection of these two. Real part of s is greater than minus 3, real part of s is greater than minus 2. Intersection of this will become final ROC, common ROC of these two. So if you observe, I am plotting two ROCs. So the first one, first pole s equal to minus 3. Here we have two poles. Two poles here we have minus 2, minus 3. So take two poles minus 2 and minus 3. Right? And ROCs, we have two ROCs greater than minus 2, first one, minus 3, greater than minus 2. So this is the greater than minus 2, green color. And another one greater than minus 3. I am doing it with red color, greater than minus 3. So this is a greater than minus 3. So where is the common ROC? That will be the final ROC. From where we are getting common ROC? Greater than minus 2, right or not? Green and red. So final ROC is real part of s is greater than minus 2. So this is the way of doing ROC whenever you have two or more ROCs in the given signal. Intersection of all. Here we have 2, so intersection of 2 is greater than minus 2. This will become final ROC. Okay friends, thank you. Watch videos regularly. Thank you.